Okay, so who's first? Who's got a question? Okay, Cindy. All right, so we are going to, this is on 4.5 homework, and we are going to sketch this problem. All right, paying close attention. We're going to sketch this. The first thing that I need to do when I sketch it is get that 1/3 out of the parentheses. So I'm going to pull that 1/3 out, I'm factoring it out. Factoring is division. So to figure out what number goes here, I have to take pi over 8 and divide it by a third. So that's pi over 8 times 3 over 1, so this number is 3 pi over 8. Factoring is division, so I divide it out. Now this is a secant. Secant is the reciprocal of the cosine. So I'm going to pretend for a moment that this is a cosine curve. In other words, I am going to sketch something that looks like this. Half a hill, valley, half a hill. That's a cosine. However, because of this, it will be starting over here at -3 pi over 8. And it will be starting up a half. So my normal cosine starts here, shifted, phase shift, horizontal shift, left 3 pi over 8. So here we go. I got half a valley, or half a hill, I mean. Now my whole valley goes down to half. And then the other half of my hill. So there's my cosine. Under normal circumstances, a cosine has a period of 2 pi. Not this one, because this number divides the period. So 2 pi divided by a third is 6 pi. So my period, that is from this hand to this hand, is 6 pi. So this guy right here is the starting point plus 6 pi. That's what's going to be that label right there. Because I'm starting at -3/8 and I'm taking 6 steps. So where will I end up? Well, I'll get a common denominator. So it looks like -3 and 48. It looks like this is going to be 45 pi over 8, -3/8 plus 6. Add those two fractions together. This is the middle of -3 and 45. The middle of -3 and 45. So let's average. -3 plus 45 is 42. Divided by 2 is 21. So this is 21 pi over 8. This is the middle of -3 and 21. My scale is way off. But the middle of -3 and 21, -3 plus 21 is 18. And divided by 2, 9 pi over 8. This one is the middle of 21 and 45. So 21 and 45 is 66, 33. Now you can always check these. How far is it from -3 to 9? 12? And then 9 to 21 is another 12, and another 12, picture of the cosine. Not quite done, but two more things. First of all, we have to recognize this is a secant. So wherever we cross the x-axis, we have an asymptote. Wherever it crosses the x-axis, that's your asymptote. Then your parabolas flip. So this thing gets flipped, this gets flipped, and this gets flipped. Not quite done. Because we still need to lift it up one. So this is a half, this would be one, this would be 1.5 right here. So that point is going up one, it's coming up to 1.5. This guy's coming up one. This guy's coming up one. The asymptotes don't change. Just the parabolas get picked up. So the pink is the answer to the question. What is the period? 6 pi. We figured that out when we graph it. Frequency, 1/6 pi. Phase shift, -3 pi over 8. Vertical shift, up 1. And amplitude, none, no amplitude. The only curves that have amplitude are sine and cosine. Everything else has asymptotes and goes forever. Okay? Every secant and cosecant that you graph, those are the steps that you're going to go through. Okay? All right, who else has a question? Yep.
On 3 on the quiz, what were you asking for?
Where's the solve?
Yeah.
X. It's an equation. What is X? All right, so we're solving for X. So we talked about this. How do we get started? There's a little bit we have to do before we get started.
Add 1,
We're going to add 1 and divide by 2. So your job is to find the angles in radians. And you can find them first in degrees and switch them to radians if you want. But the answer has to be in radians. That's radians there. And the angle, the cosine, is a positive 1/2. So somewhere here, the cosine is a half. That means adjacent is 1 and hypotenuse is 2. So certainly that could happen right here. Wouldn't you agree with me? I could have a triangle right there like that. This would be √3, and this angle right here would be 60, which is a third of 180, so pi/3. But there's another place where you could also have adjacent is 1 and hypotenuse is 2. Which one? 4. Right here, isn't adjacent still 1 and hypotenuse 2? So this angle's pi/3, but I need to know this one. Remember, this is 0. This is where we start measuring. So we're going to come all the way around to this line. How big is that angle? Well, in degrees, it would be 300, because it's 360 minus 60. But what is it in radians? 2 pi minus pi/3. Guys, look, all the way around is 2 pi. This is pi/3. So isn't that angle 2 pi minus pi/3? Which is 5 pi/3. So that's the answer to the question. Which angles have a cosine of 1/2?
Can you do number 9 on the quiz?
Number 9. What is the period? Well, what's our strategy to these problems?
You take, you the, I know what you do, I don't know how to explain it.
We find the period of each piece.
Yeah.
So the two pieces are -3 cosine 4x and 5 sine 3x. So we find the period of each piece. This is a cosine, that's a sine. The standard period of sine and cosine is 2 pi. So 2 pi divided by 4, which is pi over 2. So the period of this one is pi over 2. Now what does period mean? Period means it goes pi over 2, and then it starts over again, right? Every half pi. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and so on. That's when this curve is starting over again, every half pi. What about this one? 2 pi divided by 3? So 2/3 pi, another 2/3 pi, another 2/3 pi. So 2/3 pi, 4/3 pi, 6/3 pi, 8/3 pi, and so on. That's when it's starting over again. The period of the thing is the first time that they both start over together. Right? So, in other words, the first matching number in the list is what the period is. So, notice that this right here is 2 pi, and this right here is 2 pi. So when is the first time they both start repeating? 2 pi, and that means the period of the thing is 2 pi. Okay, Jimmy?
Yeah.
Not sinusoidal, that wasn't a question, but it's not a sinusoid because these two would have to be the same, and they're not. It's still periodic, I can still find the period, but it's not a sinusoid. All right, what else? Anything that I handed back? I handed back a lot of homeworks, I handed back the quiz, I handed back lots of stuff.
Number 8 on the quiz.
Number 8 is a problem just like this one. The difference is the angle will not be special. So let's see, I'm gonna solve. So I'm gonna add 3 and divide by 9. So this says somewhere out here, there's an angle, and the opposite side is 7, and the hypotenuse is 9. Now, you see what I mean? It's not special. 7 and 9 are not 1, 2, or 3, right? So I'm going to go ahead and draw a picture of it here. This is what it looks like. But I'm going to need help finding that angle. I cannot find that angle without a calculator. If this were a 1 and that were a 2, I can do that. Not this. So I'm going to go to my calculator, and I'm going to find the angle whose sine is 7/9. What angle? And the directions are the same as before. So I need to make sure I'm in radian mode. So I make sure I'm in radian mode. I'm not. So I'm going to change that. And then I move the second sine 7/9. And I got 0.891. That angle is 0.891 radians. Okay? 2 pi, yeah, there's no degree marker. 360 is the degree number. Now, like the another triangle that I could draw that would have opposite of 7 and a hypotenuse of 9. Where would that be? Quadrant 2. Isn't that going to be the same thing? So this is still 0.891. You never need to recalculate. The angle's the same. But the answer to that angle is right here. This is the angle I'm looking for. So that's what I need. How am I going to find that? 180 minus that would be what I do if I were in degrees. But since I'm in radians, it will be pi minus it. So pi minus that answer, 2.250. So both of these problems have two answers. They always do when you solve a trigonometric equation. Unless it's some weird situation, you're going to have two answers because there'll be two quadrants that will happen in. Yep.
Can you go over number 1 on homework 4.6?
4.6. Homework. I just got to do that on my calculator. Just type that in on my calculator. So I have to be careful when I type it in because I type it differently than I write it. When I write that, it's negative 10 squared. But when I type it into my calculator, it'll have to look like that, yeah. So it tells me that negative 2 pi to 2 pi. So this is x min, this is x max. Clearly I am in radians. Guys, 2 pi is a radian measure, it's a radian revolution. If we were in degrees, what would this say? It wouldn't say this. If we were in degrees, it would say negative 362, 360. And there would be a little degree mark there to signal to you that you are in degrees. This is in radians, right? So I think I'm in radians, I am. So I'm going to set my window, x min, x max. I'm just going to, for the time being, leave my y's at negative 10 and 10. I don't know what I'm supposed to do with those. I'm going to type in this equation. So I'm going to have a negative sign, and then I'm going to have a parentheses, and then I'm going to have a tangent. That parentheses will automatically come in. So I hit x, then I'll have to close it, close the big one, and then square it. Now, what I see on my calculator, and it's going to depend on the sophistication of your calculator. Mine isn't very sophisticated. So I have this, and I have this, I have one over here, this, and I have one here, right? So now I need to rely on, because my calculator isn't perfect, I need to rely on my own knowledge of the tangent. What does a tangent look like? Asymptote, this, right? When you square it, that makes everything positive. So that's going to push, this guy is going to push up, and I'm going to have that like that. But then when you put a negative sign in front of it, it reverses it. So that explains this, right? But does that squaring and flipping and all that do anything to the asymptotes? No, they're still there. So there need to be asymptotes in between these guys. You may not see those on your calculator. I don't see them on mine. But they're there because they're an integral. I mean, it's a natural part of the tangent. You would not have that in a sine at all. Okay, what else? I know that in quadrant one, x and y are both positive. That's a point. Positive x, positive y. Negative x, positive y, negative x, negative y, positive x, negative. Everybody okay with that? I started putting letters in. Just the signs, but- Okay? Cosine. Associated with which letter? What is the definition of cosine? X over R. If you, guys, you need to know that. If you don't, then you certainly know SOHCAHTOA, right? Cosine is adjacent over hypotenuse. In a circle, won't that be x over r? Cosine is adjacent. Adjacent is x. So if I want cosine to be negative, then I need to look where x is negative. So where is x negative here in this setup right here? X is negative here or here. So this right here, and you can start with either one, I just started with this one. This one narrows it down to either quadrant 2 or 3. Now do the same thing with that. Only sine is opposite over hypotenuse. So sine is associated with y. I want it to be positive. Where is y positive? Here and here. So quadrant 1 and 2. The only place they overlap is quadrant 2. Does that make sense? If we were talking about tangent, what is the definition of tangent? Tangent is opposite over adjacent, so it's y over x. So you have to look at both y and x if you're doing a tangent problem. Tangent is negative here. Tangent is positive here. Get it? You don't have to think about r. Sine is y over r. Don't worry about r because r is always positive. So there's no point. It's not part of the conversation. It's all at x, y. That's it. X and y. Gordon? 4b, if I'm secant of pi over 2. Pi over 2 is how many degrees, Morgan? 90. So we're finding the secant of 90. And what is special about 90? It's quadrantal. It's on the line. So remember when they're on the line, when the angle is on an axis, no triangle. We're not doing a triangle, we're going to do our circle. Secant is the reciprocal of the cosine. Since cosine is x over r, adjacent over hypotenuse, then secant will be r over x. So in this situation with that angle, I know x is 0, y is 1, r is 1. R is always 1. So when I put r over x, what happens? I get a 0 in the bottom. And what about zeros in the bottom? Yeah, they're fine. All right, what else? I want this to make sense to you, so ask. What do you still have? Like anything I turn back home works. Brian?
4, 6. Would I have to type that?
that's your clue. Your calculator is in degrees. If it says, what's the tangent of 5 pi over 9, is there a degree mark there? No degree, radians. Okay? If it's a degree, if your calculator is supposed to be in degrees, there will be a degree mark. Question 7 could have been answered 2 different ways. And some of you did it in radians and some of you did it in degrees. Isn't question 7 asking for an angle? Yes. But it doesn't tell me how to measure the angle. So both answers are perfectly okay for that one. So we got a bird in the top of the tree. The tree is 19 feet tall. Worms down here. The worm is 24 feet from the base of the tree, and we want to find the angle of depression, which technically is right here. That's the angle of depression. But remember, you have alternate interior angles, so angles of elevation and depression are the same, always. Okay, if I'm standing up here looking down at Michael, and Michael's looking up at me, our angles are the same. So I'm gonna put it here. That is awkward. Right here. So the tangent of x is 19 over 24. To find an angle, I need the inverse function. If I am in degrees, I will get one answer, which is perfectly fine. If I'm in radians, I'll get another one, which is perfectly fine. When I type that in my calculator. All right, are we done with all these papers then? All right. So now what I want you to do is get out your review packet. We have done the first page and the second page of the review. And last time we were together, we were looking at the thing called review sheet 4. I'd like to go to the back side of that, to the thing called pretest. So it's on the back of page 3. It's called pretest chapter 4. And the starred problems are calculated. That's what the code is. Alright? There's a couple I want to do, and then I will let you get, but today, this is the worksheet I want to focus on. So let's look at number 1. No calculator, don't need one. Find the value of all the functions. So we're finding sine, cosine, tangent, cosecant, secant. We know that the cosine is -2/7, which automatically means the secant is -7/2. For your test, you will not have your green sheet, but you'll have part of your green sheet. Part of the green sheet that you'll have, I'm circling right now. Part of the green sheet that you'll have is the circle part. Ideally, at this point, you know what these things are, but if you still don't, they will be on your sheet. What you will have to figure out though is, where am I going to draw this triangle? What do I know about it? I know its cosine is negative. Look carefully at the whole problem. What else do you know about it? It's between pi and 3 pi over 2. What does that mean? Where is pi? Pi's over here, right? Where's 3 pi over 2? Down here. So if I'm between, aren't I in quadrant 3? Isn't that what I'm told? And if I know cosine adjacent over hypotenuse, or x over r, can I find opposite, or y? Yes, doing what? A squared plus b squared equals c squared, otherwise known as the Pythagorean theorem. So 4 plus a squared is 49. So I got the square root of 45, which is 3 root 5. Be careful. See where that 3 root 5 is? That's negative. Because of where it is. Does that make sense to you? So now I can answer the rest of the questions. What's the sign? Negative 3 root 5 over 7. So cosecant is negative 7 over 3 root 5. I just did that. Tangent is 3 root 5 over 2. So cotangent is 2 over 3 root 5. Easy? All right. Let's look at number, I'm open to look at anything you want to. So if you see something I'm not doing, just say the word, we'll do it. I'm looking at number 3, it's a sketch. It's way easier than the one we did earlier. First of all, it's a sign. Second of all, it's already factored out, this number. And third of all, there's no vertical shift to work on. So this one's gonna be pretty straightforward. It's a sine curve, so I know it's gonna have that shape. But it's not going to start at the origin. Where's it going to start? Pi over 4. So it's a regular old sine curve. Amplitude is 2, that's this number right here. And now I gotta figure out where it ends, and it's going to end at pi over 4 plus the period. So I gotta figure, this is a period. I gotta figure out what period is. Well, for all signs, the period is 2 pi. But this one has been divided by 2. So the period is 1. So I'm starting at a 4th. And I'm adding 1. Doesn't that put me at 5/4? This guy's right in the middle of 1 and 5. So right in the middle of 1 and 5 is 3. This guy is right in the middle of 1 and 3. I'm going to write 2 4s, but you would also write 1/2 pi. which is the same as 1 pi. What is my period? Pi. That means my frequency is 1 over pi. What is my amplitude? 2. What is my phase or horizontal shift? Pi over 4. What is my vertical shift? 0. I don't have one. We can pass some up now. We got it. It's supposed to start at origin. It doesn't.
What's the frequency?
Reciprocal period. It's how many cycles are completed in a given linear line. It's reciprocal period. Alright, let's look at number 9. In which quadrant am I? Now let's see if we can figure this out. Cosine is negative and sine is negative. Where does that happen? Cosine is x, sine is y. I need them both negative, that is quadrant 3. Quadrant 3. Also be sine and cosine on both. Number 10. Find the exact value. This is obviously no calculator problem. We are not rounding things off. We want to find the exact value of this. What does that notation always mean to me? So somewhere out here, there's an angle. Now, what do I know about that angle? I know that his sine is negative root 3 over 2. So let's just stop right there. His sine is negative. That narrows it down. If the sine is negative, we have to be in quadrant 3 or 4. Does anybody remember the rules associated with the inverse functions? If that number is positive, we always look at quadrant 1. If it's negative, there are rules, and for sine, it's quadrant 4. These problems only have one answer, because they're functions. It's called an inverse function. So there's only one answer. And the rules, they're somewhere in your notes, you wrote them down, hopefully. For the inverse sine, if that's negative, I'm in quadrant 4. This is root 3, this is 2, this is 1. Can you tell me about that angle right there? That angle is a 60. Do you agree with that? Now, it's also pi over 3. There are no directions here to tell me which way to do it, so it's one or the other. 60 or pi over 3. But that cannot be the answer. Because kids, 60 is in between 0 and 90. Isn't 60 up here? So I don't want positive 60, I want negative 60. Or negative pi over 3. Because I gotta be in quadrant 4. So whatever I name my angle, it has to be in quadrant 4. It would be not full credit, because sine and tangent are the ones in 4, and they're only defined between negative 90 and 90. So you have to say negative, okay? Now, the other problems we did where we said 300 had these, well, they weren't degrees, but they had directions like this. That means you have to be between 0 and 2 pi, which means you gotta be positive.
Okay.
So that would be 300. Is it incredibly confusing? Yes. It has to do with the graphs of the verses. Just remember that for sine and tangent, quadrant 4 is negative. Cosine of quadrant 2 is some factor. But sine and tangent is. All right, a couple more here. Now number 11. Still not a calculator problem. Jimmy told us this means there's an angle. And its tangent is 3/4. I have no idea how big that angle is. None at all. But could I find the hypotenuse of the triangle? So 4 squared plus 3 squared, that's going to be 5. I still don't know how big that angle is, and I don't care, because I want to know the cosine. Cosine of that angle. So the answer to the problem is simply 4/5. This one, I actually had to find the angle. But that was okay, because the sides were sides I recognized. This one, I don't recognize those sides, but it doesn't matter, because all I want is the cosine. All right, and number 12. What is the period of the first half of number 12?
1/2 of the
2 pi divided by a half, so it's 4 pi. Now, what does that mean? This thing repeats at 4 pi, 8 pi, 12 pi, and so on, right? What is the period of the second one? 2 pi divided by 2/3 is 2 pi times 3/2. 3 pi. So this one repeats at 3, 6, 9, and 12. There it is. What's the period of the function? 12 pi. The first time that they both start over again. Number 6. Write the equation of the curve. Some of you forgot what these equations look like. Remember, it's something sine, something, parentheses x minus something, and then plus
Or minus.
or minus. Yeah, I'm gonna put a plus to get these letters back. Okay, so that is the structure of your equation. I'm also going to do a cosine, but I have to do one or the other first, so I'm using sine. Now, if I look at this part of the curve, do you see a sine? Now, I know there's a little bit more drawn, I get it, but do you see the part I've drawn as a sine curve? That is a sine curve. And it is a positive sine curve with an amplitude of 3 and a phase shift of negative pi over 10. It's starting here. So in my equation, that will be x plus pi over 10. The high point of the graph is 3 and the low point of the graph is negative 3. So I have no vertical shift. What happens when you have a vertical shift? The top is at 6 and the bottom is at 2. right? That means you're moved up. But if you are up 3 and down 3, you're right where you're supposed to be. You have not been shifted. Okay? I don't know why we have such a hard time with this number. We gotta get it figured out. How did I find period over here? I took 2 pi and divided it by the number in front of the x. So my period is 2 pi divided by the number in front of the x, which I don't know. But I do know my period. How far is it from negative 1/10 to positive 3/10? How far is that? Negative 1 to 3. 4/10. So my period is 4/10 pi. Or pi over 10. My period always equals 2 pi divided by that number. So 4 pi n equals 20 pi. I'll divide by 4 pi. And it looks like that number is a 2 pi. Cosines and cosines. 2 pi divided by the coefficient on x gives you your period. Now, what does my cosine going to look like? Well, all of it is going to stay the same, except possibly that might be negative depending on what I look at. And then where I start, obviously, will be different. So if I'm looking at this as a cosine, would you agree I could look at that part right there and that would be a cosine? It is starting exactly where it's supposed to start, so there is no shift. And it's not upside down, so that is still positive. There they are. Your job for tomorrow. I want you to focus your energy on that page, the ones we haven't done. And on the next page, it's called practice test. Alright? So focus all your energy on the page you were just working on and on the next page, which is called practice test. Tomorrow when you come to class, I need you to ask me questions about what we need to review. Okay? Huh? Oh, it's due. I can't remember. It's 4:18
Let's
today.
see, Carol, get back to today. There's a couple quick announcements. First of all, there's math in the chapel at 11:50 with Auto Dummy. Secondly, there's Black History Month trivia.